Welcome back to my YouTube channel. Please, I need a lot of encouragement from you guys. Please, by subscribing on my videos and hit the notification button so you get notified anytime I upload a new video. So please, I'm waiting for you guys. Yeah, you watching the video, please subscribe right now. Subscribe. So thank you guys for subscribing. So we're going to be looking at another question. Yeah, this is a question on thermodynamics, basically, also on fluid mechanics, actually. So now, so now, the question we have before us here is 2 meter cube of air at atmospheric pressure of 1.01353 bar are compressed to 0.50 meter cube. From isothermic condition, what is the final pressure? Now let's pause and take that first aspect. So now, before we solve this kind of bulky question, let's write out the parameters. So solution. So now, writing out our parameters, we're given 2 meter cube of air, right? So this is our volume. Let's call it V1, 2 meter cube, and the air is compressed. Now at this atmospheric pressure, which is a standard pressure, let's call it P1, 1.01353 bar. Now let's convert this bar to Newton per meter square because that's the standard unit for pressure. Converting it, we have, since 1 bar is basically equal to 10 raised to power 5 Newton per meter square. Replacing this, we have 1.01353 times 10 raised to power 5 Newton per meter square. So that's that. Then it was compressed. The air, atmospheric pressure at this pressure, was compressed to 0.5 meter cube, which is our V2, 0.5 meter cube. Now, what did they ask us to find? They asked us to find at isothermal condition what is the final pressure. So we're looking for final pressure. Now, before we go into the rest of the question, let's first solve this aspect. So now, what is an isothermal process or an isothermal condition? Basically, where we have a constant temperature, right? So basically, for gas, we know that it is actually following Boyle's law. So say temperature is constant, right? So we'll be having, since for isothermal condition we have a constant temperature, will be given as P times V is equal to constant. This is basically Boyle's law in chemistry, but this is an isothermal process in thermodynamics. So having given this, since PV is equal to constant, that is my isothermal condition, we'll be having P1 V1 is equal to P2 V2, right? So given this particular formula, we're going to be applying it to solve. So since my P1 is 1.01353 times 10 raised to the power 5, right, times my V1 is what, 2, equals, I'm looking for P2, right? Then my V2 is equal to 0.5. So dividing both sides by 0.5, dividing both sides by 0.5, my final pressure is equal to 1.01353 times 10 raised to the power 5 times 2 divided by 0.5. Is equal to 405,412 Newton per meter square. So let's convert this into bars. First, we have, converting this, we have 1, 2, 3, 4, 5. We have 4.054 times 10 raised to the power 5 Newton per meter square. Now, since 1 bar is 10 raised to the power 5 Newton per meter square, we'll be having 4.054 bar. So this right here is my final pressure, which follows the fact that when there's a decrease in volume from 2 to 0.5, there is an increase in pressure from this to this. So now let's go back to our second question, which says, what is the final pressure if no heat is lost due to compression? Now, in this case, we're talking about an adiabatic process. An adiabatic process is a process in which there is no change in heat despite change in temperature. So there's no heat change from the system or within the system and the surrounding. So now I have to find the final pressure when there is no heat change or during adiabatic process, and they basically gave us the representation or the relationship of an adiabatic process. So basically, an adiabatic process has a relationship P V raised to power K is equals to constant, where K is called an adiabatic constant. Adiabatic constant. So basically, for air, the adiabatic constant is equals to 1.4. So that's what we're given in the question. So basically, we have to find the final pressure in them when it is in an adiabatic condition or an adiabatic process. So basically, we're going to be working with our same parameters V1, V2, P, and P1. So we'll be having here P1 V1 raised to power K is equal to P2 V2 raised to power K. Right? So my P1 here is what? 1.01353, right? Times my V1 given in the question is what? 2, right? 2 times 2 raised to power my K, which is what? 1.4, equals my P2, which is what I'm looking for, right? Times my V2, which is what? 0.5, right? So we're having times 0.5 raised to power 1.4, right? So dividing both sides by 0.5 raised to power 1.4, dividing both sides by 0.5 raised to power 1.4, then my final pressure is equal to, solving this, we'll be having 7.058 bar. Yeah, so our final pressure is just 7.058 bar. So that is the final pressure for adiabatic process. Thank you guys for watching, and please subscribe.